Okay, so chapter 7, we have gravitation. So we are going to look at everything about gravitation. So first of all, let us go through a quick revisions. See what is the things that we have to know in the chapter 7. So first of all, we have a force. Okay, so there are three quantity that we have to know in this chapter, which is a F, and then E, and then after that we have something called U, potential energy. Okay, we have something called U, potential energy, and then after that we will have to look at everything's about satellite. Okay, the escape velocity of a satellite, and then the velocity, the periods for satellite. So we are going to focus on these three things first. Okay, the force, and then the E, which is a field, and then the U, potential energy. Force, we have F equals to G capital letter M small letter m over R squared. All right, so if you remember what did I told you guys before, you have to be extra careful with the mass, right? So we have two different M, one capital letter M, one small letter m. But when it comes to force, okay, it is not that obvious yet, the importance of the M. Okay, because force mainly you're looking at what happens between two masses. So M1, and then this is your M2. Okay, so M1 and M2, when you place two masses together, they always will have an attractive force between them. For example, even between you and your friends, your family members, all of you, you actually have a gravitational force between you. Just that the force is very, very, very small and it is negligible. Why? That is because of your G. Okay, your universal gravitational constant. G is equals to 6.67 times 10 to the power of negative 11 and m squared kg negative 2. So because of this constant, it has a very large negative power. Therefore, okay, it has a very large negative power. Therefore, your mass becomes very insignificant. Okay, the force between you and everything surrounds it becomes negligible because of this power. All right, and then we have a E. Okay, we have a E where E is equals to F divided by A. Okay, and now this A, we call it AG because it's the accelerations due to gravity. Okay, it is the accelerations due to gravity. Wait, I put the wrong item here. It's not A. It's your M. Okay, this is your AG. Sorry, I put the wrong quantity here. This is your AG, which is the field. Okay, gravitational field strength. So F and then AG, not E, sorry. So F and then AG and then followed by U. So AG is your gravitational field strength, and then it is F over M. All right, F over M give you a field strength. So field strength, why is it so important about the field strength? Okay, field strength, that is because it can only feel the force if you place object and other masses within the field. All right, if you place this outside the field, then there is no gravitational force between two masses. Okay, so first things we have F, the second things we have AG, and AG, when you substitute GMM over M into the equations, what are you going to get? You will get a new equations that comes with capital letter M only. Okay, GM over R square. So this GM over R square, your capital letter M, okay, your capital letter M, it refers to point mass. Okay, it refers to point mass. So point mass, usually we refer to the object that is not moving in our questions. All right, test mass is the mass that you move around to test different value. That is what we call test mass. So in these equations, we cancel out the test mass already. Okay, the small letter m in the equation, we cancel it out. So we are left with just capital letter M. So we are just looking at the object that is not moving. Right, usually it refers to the planet. And then potential energy, we have a GMM over R. Okay, so you calculate the energy between two masses to place one object from infinity into the field of the point mass. All right, so small mass is the point is the test mass, small m is the test mass, capital letter M is the point mass. So what happened now is you have a capital letter M here. So you move the small letter m from infinity to a point inside that field. So you want to find out how many energy is needed to place it inside the field. So we use U equals to GMM over R. Now, what is the difference between U equals to GMM over R and U equals to mgh? Both of them, they are gravitational potential energy. Okay, the difference between these two equations is that once you use it for a distance that is very close to the surface. Okay, so mgh, we use it when you place an object that is very close to the surface of the earth. Okay, to the surface. So for example, okay, you're standing on the surface of the earth. Therefore, when calculate the potential energy for you, we use U equals to mgh. Okay, where we assume Ag is constant, is a parallel straight line when it's close to the surface. So actually Ag is equals to your G. Okay, just that we use them in a different context, therefore we use different symbol, right? So for U equals to GMM over R, we use it for when your object is very far away from the surface. Okay, when the field line is no longer parallel to the surface. So it's very far away. Where you can see the shape is actually spherical shape. All right, so when it is very close to the surface, then what we have, the field line, it should be pointing towards the object. Okay, it should be pointing towards the object. So when you place it very close to the object, then you will just see a rows of a parallel straight line. All right. So attractive force, the field line is going into the object. So this is for when it's very far away. When it's very close, this is what we're going to see. So this is a flat surface. So the field line is just a rows of a straight line that is parallel to each other. Okay, so this is for U equals to mgh, and this is for U equals to GMM over R. So it's very hard to tell which one to use actually, okay? So it's based on the informations given in the questions. All right, now let's look at questions 1. Okay, questions 1, that is what I told you just now, okay, where you can actually feel you are actually having the force between you and your friends, you and your family members. So Tisha's and Edwin's with masses of 50 kg. So this is my M1, and 70 kg, this is my M2, respectively, are sitting on a bench. They are separated by a distance 0.5 meter, which is your R. Calculate the gravitational force between Tisha's and Edwin. So what is the gravitational force between them? So now I have M1, M2, and R. I want to calculate force. So F is equals to G M1 M2 over R square. So you plug in the value 6.67 times 10 to the power of negative 11 times with 50 kg and then times with 70 kg divided by 0.5 squared. All right, so you press your calculator, you will get 9.34 times 10 to the power of negative 7. Now, this one, you don't even have to memorize the unit, all right, because you are looking at force. So the unit for force is always Newton. So don't be confused. Sometimes students, they get confused because of what? Because they say the G, it comes with such a complicated unit. So what is the unit that should be used in a gravitational force? No, you don't even have to think. Why? Because gravitational force is a form of force. Whenever it comes to force, it doesn't matter what type of force, the unit is always Newton. Okay? So pelajar dia sentiasa keliru. Sebab apa? Sebab dia kata G punya unit begitu rumit sekali. So macam mana nak derive unit untuk F? Tak payah derive pun. Kamu tengok gravitational force, you have force. So it doesn't matter what type of force. As long as it is a force, you know the name is called force, then it is Newton. Alright, so after you calculate, now as you can see here, the force between two persons, two humans, maybe between you and your friends, is up to 9.34 times 10 to the power of negative 7. So it is very, very, very small. Okay, until you don't feel anything between you and your friends. Okay, and actually that is a good thing. Try to imagine if you walk around, okay, kamu sambil jalan and then sambil tarik kawan kamu, then everyone will be attracted towards you. That would be horrible. Okay, then you are just like a piece of magnet.
Madam,
Yeah,
yang G tu, G besar tu, nilai dia akan bagi dalam exam ke kena
G besar sebab dia panggil gravitational constant. Okay, gravitational constant, dia bukan G kecil. G kecil is your gravitation, acceleration due to gravity. Apa?
My question is, dalam kita punya test nanti,
Yep.
dia akan bagi ke atau kita kena test sendiri?
Sebab kamu punya exam, sekarang format exam, final exam punya format, macam mana sebenarnya kami tak tahu lagi. Okay, kalau ikutkan dulu, memang dia akan diberi. Sebab face-to-face punya exam, memang list of concern akan diberi. Tetapi sekarang kami tak tahu sama ada kamu akan ada face-to-face punya exam ke, atau kamu akan ada yang online punya exam. Kalau online punya exam, kamu sendiri yang kena sediakan semua ini. Okay, tapi saya akan bagi kamu senarai juga lah. Nanti kamu cuma kena print out. Okay, kamu print out and then kamu boleh rujuk. Tapi
Okay.
kalau face to face memang dia akan bagi. So all these constant you don't have to memorize the value, you don't have to memorize the unit. Alright. So now questions 2. Okay. The average distance separating Earth and the Moon is a 384,000. Now, even though the question gives you such a huge value already, but if you look at the unit, it is still in terms of km, so you have to be extra careful. Chapter 7, the problem is the unit. Okay, they often give you unit in km, so you need to change it into SI unit. And then a spaceship of a mass 3 times 10 to the power 4 kg is travel from the Earth to the Moon. Determine the distance of the spaceship from the Earth at which the net gravitational force acting on it is 0. Now, what does it mean? So now you have a spaceship from the Earth and then it moves until it reaches positions. Okay, so this is the Earth. And then this is the Moon. So this is your spaceship. And I don't know where is it. Okay, I don't know where is it. The only things that I know is now the net force acting on it, total F is equals to 0. Okay, and because if you look at the definitions of gravitational force, it tells you whenever there are two masses, there must be an attractive force between them, which means there's an attractive force between the Earth and the satellite, where I'm going to call it Fe, and there's another attractive force between the satellite and the moon. Okay, we ignore the force between Earth and the moon because now our object is the satellite. Okay, our object is a satellite. So it's not a satellite, sorry, it's the spaceships. So our object is the spaceships. So our main focus would be what happens to the spaceships. What is the force that is acting on the spaceship right now? Okay, so you don't have to look at the attractive force between Earth and Moon. What we want is just attractive force between spaceships and the Earth and a spaceship and the Moon. So according to my diagram, okay, now I'm going to sketch a free body diagram for this part. Aha, so free body diagram is a very important in this chapter as well. So my object is the spaceships. So spaceship is the object. And then I'm just going to sketch the gravitational force acting on it. Okay, you don't need a mass, you don't need weight and everything in this chapter. What you are going to focus on is the gravitational force. So my free body diagram, this is a spaceships, and then I have a F between the spaceships, okay, the spaceship and the moon that is going to the right. And then I have another force between spaceship and the Earth going to the left. Okay, so this is my free body diagram for the gravitational force. Okay, because our main focus is just gravitational force, so you don't have to sketch W in the diagram. All right. So Fm going to the right, Fe going to the left, and according to the questions, the things that I know right now is a total F is equals to 0. Right? Total F is equals to 0. So what does it mean? It means Fm minus Fe is equals to 0. The force going to the left minus the force going to the right minus the force going to the left. It is equals to 0. Okay, because the total force, the net force acting on the spaceship is 0. So Fm minus Fe, because of the direction, therefore I use minus. If both of the force they are going to the right, then it's Fm plus Fe. Okay. If both of the force is going to the left, then again you just plus it up. Okay, you just add them up. So now I have two forces, they are pointing towards opposite direction. So I use subtraction. Fm minus Fe. So what am I going to do next? Now, if I have M, okay, I'm going to label it in my diagram. So let's see. For the Earth, I'm going to label it as M E, capital letter M, because it is not moving. Okay, and for the Earth, capital letter M as well, and then the moon, subscript with a moon. Okay, and the spaceship, I'm just going to use a small letter M. Right, I'm just going to use small letter M for a spaceship because it is actually our test mass, the object that can be moved around in the diagram in the questions. So Fm minus Fe, Fm, okay, Fm, okay, now you see, yeah, Fm is the force between Earth and spaceships. Therefore, Fe. So for M, Fm is between the moon and the spaceship. So therefore, what am I going to do? I'm going to expand the equation, green color. Okay, for Fm, I'm going to expand the equations by using G. Now the M. Which M should I use? Then you look at the diagram. Fm exists between spaceships and the moon. Okay, and the moon. So G, capital letter M for moon, times small letter m. So Fm, it has nothing to do with the Earth. So you don't put me in the first part of the equation. So over R, okay, R, I'm just going to put moon. Okay, Rm. And then minus, okay, minus what? Minus Fe. Okay, the force between the spaceship and the Earth. So what am I going to do? Again, capital letter G. Now capital letter M, and this M is for the Earth now. Okay, moon, you no longer need moon in your second force. So capital letter M for the Earth, and then the small letter m for the spaceship, divided by R E, the distance, okay, the distance between the Earth and the moon, and then equals to 0. Okay, equals to 0. But when it comes to these questions, there will be an issue. Okay, let's go back to the questions again. The questions give you what? It gives you the distance between what? The distance between the Earth and the moon is 38400 km. You don't have the informations about the distance between the Earth and the spaceship. You don't have the informations between the distance between the spaceship and the moon. All right. So what should we do in this case? So let's see. I have a 3 distance here. So the distance between Earth and moon is 384,000 km. Right, so to be more precise, it should be 3.84 times 10 to the power of 8 meter. Okay, 3.84 times 10 to the power of 8 meter. So what should I do next? Now, I have the distance between the Earth and the moon, but I don't have the distance between the Earth and the spaceship. Okay, therefore, to make it easier, I'm going to label here as X. Okay, I'm going to label here as X. So why I label this one as X but not the other one? Because the question is asking for the distance of the spaceship from the Earth. So it wants you to calculate the value between the Earth and the spaceship. So for the Earth and spaceship, I put X. Then how about the other part? This part, should I put Y? No. Okay, you shouldn't put Y. We try to decrease the amounts of unknown in our question. All right. So to control the amounts of unknown, okay, now we try to think, is there any ways that we can use, okay, we can write here to reduce the unknown. Alright, not to create a new unknown. Jangan letak Y. Kalau kamu letak Y, dia akan jadi 2 unknown dalam equations Anda, iaitu X dengan Y. Okay, apa yang kita nak buat dalam soalan? Kita nak kurangkan bilangan unknown. So how? Well, we know the distance between moon and the Earth is 3.84 times 10 to the power of 8. We know the distance between the Earth and the spaceship is X. Therefore, how about the distance between spaceship and the moon? Well, by using 3.8 times, this one is too thick. Wait, yeah, let me change
minus
the pen.
X.
Yeah, good. Okay, so minus X, we can reduce the unknown. Okay, kita boleh kurangkan unknown dengan guna 3.84 times 10 to the power of 8 minus X. So in this case, you will only have 2 unknown in your question. all right, which is x. One unknown, one unknown in your questions, which is x. So apa yang kita nak buat sekarang? Just now ada square-nya, saya termakan square. So what am I going to do now? I'm going to substitute the value into the equations. Okay, but if you look at this equation, okay, I'm just going to rearrange it first. GMM over RM square equals to GME M over RE squared. Now, according to this equation, what can I do? I can simply cancel out the mass of the spaceship. I don't need the mass of the spaceship actually. All right. So after I cancel it out, I'm just going to plug in the value. The value for what? The value for G. G also can cancel it out. Okay, G pun tak payah actually. So what we need is just MM, RM, ME, RE. MM is a constant value that is given, and ME is also a constant value that is given. So MN given, okay, according to the questions, kita ada 7.35 times 10 to the power of 22 divided by, now RM according to the question is 3.84 times 10 to the power of 8 minus x, okay, minus x squared equals to, so the mass of the earth is given 6.00 times 10 to the power of 24 kg. Okay, so this is for the earth divided by x squared. Okay, x squared. Okay, next. So what are we going to do then? Now, to make it easier, okay, I won't recommend my students to expand the equation. Okay, saya memang sangat tak galakkan pelajar saya expand equations. So what you should do, okay, you rearrange the equation. Okay, you rearrange the equation. So how to rearrange? Now it becomes x squared divided by 3.84 times 10 to the power of 8 minus x squared equals to 6.00 times 10 to the power of 24 divided by 7.35 times 10 to the power of 22. So after you rearrange it, okay, kamu kumpulkan semua benda yang ada square on the left hand side, then you square root both sides. Okay, you square root both sides. So after you square root it, what happens? You can actually remove the square. So dia akan tinggal x over 3.84 times 10 to the power of 8 minus x sahaja, square gone. Okay, because you square root it. So by square root both sides, okay, you can actually simplify the equations. So now this is 81.63. Okay, so rearrange the equations, you will obtain x equals to 3.46 times 10 to the power of 10 to the power of 8 meter. All right, from the earth, you have to mention it. Okay, from the earth. So kamu kena sebut dari mana. All right, you have to mention this x is from where. Okay, so that is a complete answer. That is a complete answer for questions 2. Alright, questions 2 boleh dikatakan soalan yang paling susah di dekat force dah. Alright, so if you can understand this question, means you understand exercise 1. Okay, exercise 1. So now I give you 2 minutes to write it down. Okay, including the diagram, including how to reduce the amounts of unknown, including how to do square root both sides. Biasanya pelajar salah soalan ini soal apa? Sebab dia tak tahu apa itu square root both sides. Dia tak tahu simplify. So he or she go and expand everything. When you expand everything, then the questions will become very, very complicated. All right? So to make it easier, you square root both sides to make your life easier. All right, so I give you 2 minutes to write it down. Okay, so pastikan anda faham ya. Okay, next. Okay, next one is quite similar to a previous question. So what is the difference now? The difference now is just that the net force is not equals to 0. Okay, the net force is not equals to 0, and you want to find out what is the net force. So calculate the net force on the moon due to gravitational attraction of both the Earth and the Sun, if the moon is located between the Earth and the Sun. So usually when it comes to this question, I encourage my students to draw the diagram. Simple diagram is enough, okay? So you have the Earth and the Sun, all right? And then you have a moon in between them. So you don't know where is the moon yet. Or are you given? Yes, you're given. So distance between the Earth and the moon and distance between the Sun and the moon you are given here. Okay, so this one, let's call it RE. RE, you have a known value. Okay, RE, and then this is your RS. Okay, your RS. So you have enough informations. So you even have a ME, and then the MM, MS. So questions asking for net gravitational force. So what do you need? Now you need to draw a free body diagram for the moon, because questions say you want to find the net force of the moon. Okay, net force on the moon, which tells you that now the object in our question is the moon. So even though you have a larger object, the Earth and the Sun, okay, but then the moon, okay, the moon is our main focus here, because question is asking for force on moon. So when it comes to chapter 7, another things that you need to take note is to identify the object in the questions. Okay, which one is our object? So this is a moon. There's a gravitational force between the moon and the sun. Okay, so I'm going to put an Fs going to the right, because the force between two masses, they are always an attractive force. Okay, they are always an attractive force. And then another force between the Earth and the moon. Okay, so I have another Fe that is going to the, okay, that is going to the left-hand side. Question asking for net force. All right, so net force now is asking for summations F. But summations F now is no longer equals to 0, because it has a value. Okay, so straight away equals to, now based on my diagram, Fs going to the right, Fe going to the left. So Fs minus Fe. Okay, summations F equals to Fs minus Fe. So you just expand from here. So Fs, G, now M, well, because we're looking at the Fs, so Ms, and our object is the moon, so MM divided by Rs minus G, and then now the Earth and the moon. So you look at that as a force between which two objects. If it's between sun and moon, then you use Ms, MM. If it is between the Earth and the moon, then Me, MM divided by Re. Okay, so you plug in the value, and then eventually you will get 2.35 times 10 to the power of 20 Newton. And because this is a positive value, what does it mean? It means Fs is larger than Fe. Therefore, the force is toward the sun. Okay, toward the sun. Right? So you yourself have to know the direction. So since you use Fs minus Fe, okay, Fs kalau minus Fe larger than the 0, greater than 0, means it's towards S. Kalau kamu dapat Fs minus Fe less than 0, then it is toward E. Okay.
Madam,
Yep.
kalau contohlah saya buat
Yeah.
first formula yang GMSMM tu, lepas tu second saya potong tak apa ke?
Ha, mana boleh potong ini?
Kalau macam saya ubah ke sebelah, lepas tu potong yang G tu.
Tak,
G
mana boleh potong, because now your summations F is a non-zero value. Tadi boleh potong because your summations F is a zero value. So you can rearrange it. Kamu boleh rearrange dia jadi Fm equals to Fe. That is because summations F is equals to 0. So now your summation f is not equal to 0. How can you rearrange it? Here there is a value, there is a value, there is a value, just that we don't know what is the value. So this is still summations f, summations f, summations f. Kamu tak boleh rearrange sebab bukan kosong. So for these questions, you have to substitute everything into the equations and then calculate the value. You cannot simply cancel anything cell. Okay?
Okay.
So kena berhati-hati. Ini matematik ini. Kalau dia sama dengan kosong, baru kamu boleh rearrange ke sebelah kiri dan kanan. Sekarang dia tak sama dengan kosong. Tak sama dengan kosong, Anda tak boleh kata FI dengan FS sama. So kamu tak boleh buat begini. Okay? So this question is very similar to the previous questions. The difference is that now you have a non-zero value. Right? So bagi Anda 2 minit lagi untuk catat. Okay, so untuk 3 soalan ini pastikan Anda faham ya. So kalau Anda faham 3 soalan ini, exercise 2 lebih kurang sama sahaja. Okay, actually exercise 1 and exercise 2, okay, especially when it comes to exercise 2, actually you can still use the equation from exercise 1. Okay, dia sama punya actually. Alright, sebab dia punya beza cuma dekat 1M saja, but the concept is the same. The way you sketch free body diagrams, they are the same. Right? So now let's look at exercise 2. Okay, today I'm just going to discuss exercise 1 and exercise 2 only. Right? 5 soalan saja untuk hari ini, just a simple questions. Now, determines the magnitude of the gravitational field strength. Gravitational field strength, this is your AG. At a point, now this question is very tricky. Why is it tricky? Now you have the Earth. Okay, you have the Earth. And now what happened is that now this object is located, okay, is a point that is 5,000 km above the Earth. 5,000 km. But if you recall, the things that I told you in lecture, whenever it comes to chapter 7, the distance that we use is often the distance from the center until the points that we want. All right, which means in our calculation, we need to take into considerations the radius of the Earth. All right. So soalan ini memang dia keluar di exam. Okay, they like to trick the students, see whether you understand or not. So when it comes to the questions, calculations, make sure you know which R to use. Okay, our R always start from the center of the object. So informations given is 5,000 km above the surface. So which means in your calculations, your R, your actual R is actually should be equals to RE plus 5,000 km. All right, this is for questions A. So which is equals to, now my RE, the radius of the Earth, is a 6.4 times 10 to the power 6 plus 5 times 10 to the power 6. Okay, 5,000 km kan. So you have 11.4 times 10 to the power 6 meter. So that is the R that you should use in questions A. Okay, in questions A. So now we want to calculate AG. AG is equals to G. Now, if you recall, this M should be capital letter M. So capital letter M refers to a point mass. Okay, the point mass that is not moving in the question, which is the Earth. Okay, objek besar yang tak gerak dalam soalan kita. Okay, so the point outside the Earth, okay, the point that is 5,000 km above the Earth, this point, you can change the position. It's up to you to move. So this one, we call it test mass. Okay, this is test. And then this is our point mass. That is not moving. So we can change our object, but we cannot change our Earth. So GM over R squared, which is 6.67 times 10 to the power of negative 11 times with the mass of the Earth, which is 6 times 10 to the power of 24, divided by R squared. Okay, we have 11.4 times 10 to the power of 6 squared, which is equals to 3.08 ms negative 1. Oh, ms negative 2. Okay, jawapan ada salah. This is 2. So 3.08 times 3.08 ms negative 2. Okay, ms negative 2. Now for questions B. Okay, questions B, what happens now is, okay, you have an object that is just on the surface of the Earth. All right, so you need to use the RE. So your R is now equals to the radius of the Earth, which is equals to 6.4 times 10 to the power of 6 meter. Right? So AG is equals to GME again over R squared, which is now equals to 6.67 times 10 to the power of negative 11 times with the M, which is 6 times 10 to the power of 24, still the same point mass, divided by 6.4 times 10 to the power of 6, okay, which is then equals to 9.77 ms negative 2. Okay, 9.77 ms negative 2. Okay, one more thing that I forgot to mention, yeah, for the values of the mass of the Earth and also the radius of the Earth or all the other planet, you don't memorize the value. Okay, questions will give you the value, because if you memorize the value, one issue will happen. Different reference book, they use different value. Okay, if you memorize it and you use it in the exam, and the value in the exam given, okay, the values given is not the same as the one you memorized, then it will be considered as wrong. All right. So in exam, the informations, the priority of the information, first thing you look at the question. See if it is given in the questions or not. Okay, kita rujuk soalan dulu. Kita ikut priority. Priority pertama based on the question. For example, G. Okay, if G given in this question, let's say it gives you 6.7, then you have to use 6.7. If question is not given, then the second priority is the list of constant. Dia ikut begini. Okay, so even though list of constant mungkin dia bagi 6.67, but in questions they give you 6.7, then you need to use the value in the question. All right, first priority, question. Second priority, list of formula. Third priority, benda yang kamu hafal, the things that you memorize. Okay, so for example, one thing that happens very often in exam, okay, is your G. G, some questions they give you, assume G is equals to 10 meter per second. Then you have to use 10 meter per second square. Okay, 10 ms negative 2. All right, so kalau soalan bagi G equals to 10, then you need to use G equals to 10. If questions is not given, then you use the one in the list of a constant, which is 9.81. Okay, so ikut dia punya priority. First priority, question. Second priority, list of constant. Kalau kedua-dua tak ada, then baru guna yang kamu hafal punya. Alright, baru guna yang kamu hafal punya. Okay, so I give you 1 minute to write it down. Then we can move to the last questions. The last question is a very interesting question where it involve ratio. Okay, ratio memang benda yang pelajar paling lemah kita kata. Okay, your weakest link, your weakest point. So I give you 2 minutes to finish this question. Then we will spend more times on the ratio types questions. Okay. Okay, now let's look at questions 2. Okay, questions 2. The mass and radius of Earth are 81 times and 4 times respectively respectively that of the moon. Okay, 81 times of the moon and 4 times of the moon. What does it mean? It means if you use Earth divided by moon, then you will get a 81 times and 4 times. Okay, so that is the ratio. So what is the gravitational field strength on the surface of the moon? Now, when it comes to these questions, sometimes what happens is students, they go and calculate the value. Okay, well, you can, okay, there's nothing wrong. Just that it becomes more complicated. Okay, because you are not given anything, the mass or the earth of the moon and so on. Okay, you're not given anything, so you need to memorize it. Okay, now when it comes to this type of questions, first of all, you need to form the relationship. Okay, so this is a questions without any value except for 81 and 4. So how? Let's look at the questions. So the mass, okay, we analyze information piece by piece. Okay, the mass is how many times? Because mass is located beside n, right? Mass and radius. So mass is beside n. So 81 belongs to mass. Okay, 81 belongs to mass. And then the radius is located after n. So the 4 times is for the radius. Okay, so we have the informations already. Okay, we know mass is a mass of the Earth is 81 times of the moon. Mass, the radius of the Earth is 4 times of the moon. Okay, so now we form a relationship. Start from mass. So mass of the Earth divided by mass of the moon, it is equals to 81 because it's there 81 times. Okay, 81 times. And then radius. So radius of the Earth divided by radius of the moon. So it say it is equals to 4 times. Okay, so these are the informations that we have. And then let's go back to the question. What is the things that it wants? It was gravitational field strength. So this is our AG. Okay, this is our AG, the field. So AG, now let's recall. What is the equation for AG? So AG the equation is equals to GMM over R squared, right? GMM over R squared. So this is the general equation. So we often start from general equation, okay, the general equations. So once we have general equations, what are we going to do? We are going to form one equation for the Earth, and then one equations for the Moon. All right. Now we say form one equations, actually we just add the subscript. So how to add a subscript? AG for the Earth, it is equals to GME over RE squared. All right. So the one that is different, the information that is difference between Earth and the Moon, we put a subscript. If they have the same value, for example G, then you don't need to add subscript to it. Okay, bagi nilai yang sama dalam kedua-dua equations, kita jangan tambah subscript. Bagi nilai yang berlainan sahaja kita tambah subscript. So M different, so we put a subscript ME, and then R different, so we put RE, A different, so we put AGE, right? So when it comes to Moon, then you have a AGM equals to GMM over RM squared. Okay, over RM squared. Okay, so next thing, what are we going to do? So what else do we have in the questions? Now, there's one more thing that we do know, all right? The gravitational field strength for the Earth, we have the value actually, okay? Because if you recall, the magnitudes of AG on the Earth is actually equals to our G, which is equals to 9.81. ms negative 2. Okay, so this is a common sense value. Okay, the values that we call general knowledge. Therefore, we have okay, now let's keep it first. Let's let us leave it first. Okay, we'll plug in the value at the last step. So now what am I going to do? I want to find GM, right? AGM. So I have two equations now. Now, whenever it comes to the questions that involve ratio, okay, most of the times we use divide. When we form two equations, after we form two equations, we use divide. Okay, we divide these two equations to remove the same variable, to remove the constant value, okay, to throw away the constant value from our equations. So what I can do right now is, for example, now I'm going to use equations 1 divided by equations 2. Okay, so bila dia datang ke soalan ratio, kita agak kerap. Kita guna bahagi. Kita buat dua equations and then kita bahagi. Kenapa kita bahagi? Sebab kita nak buang semua nilai yang kita tak tahu. Okay, kita nak buang semua nilai yang kita tak tahu dari soalan kita. Okay, now 1 divided by 2. So I'm going to use AGE divided by AGM. Okay, AGM. So I have a GME over RE square divided by GMM over RM square. Okay, so divide, kalau kamu punya matematik lulus, then you should know how to solve it. So AGE divided by AGM is then equals to GME over RE square times RM square over GMM. Okay, over GMM. All right, so kita boleh, we can then remove G from our equation because they have the same value. You don't even have to calculate it. Now, the remaining part, you have two ways to solve it. Okay, yang seterusnya, kamu ada dua cara untuk solve dia. So, how to solve it? Okay, now let's see how are we going to solve it. First method, okay, kaedah pertama, I'm going to show you the first method first. So, method 1. Okay, so now you have a AGE over AGM. Now we rearrange the equations to become ME over MM times RM square over RE square. Okay, so you given just now ME over MN is 81. All right, So it is equals to 81 times, well, you are given RE over RM equals to 4. So M over E would be 1 over 4, but now you square it. Okay, kedua-dua punya square, you can factorize it out and then put it outside the bracket. Right? So it is equals to 5.06. Now, since we know AG is equals to 9.81, so AGM is then equals to 9.81 divided by 5.06, which is equals to 1.9. Okay, 1.9 ms negative 2. So this is method 1. Alright, ini method pertama. Now, the second method, okay, the second method, apa yang berlaku? Sometimes students, they like to rearrange the equations here. Okay, these two equations. Boleh juga, tak ada masalah. Okay, boleh juga, tak ada masalah. So second method, okay, method number 2, apa yang pelajar suka buat? Okay, now they say, okay, now my ME is equals to 81 mm. And then my RE is equals to 4 rm. Okay, then you plug it into the value. So AGE over AGM is equals to, now ME is 81 mm, right? So 81 mm over, now my RE is 4 rm. So 4 rm, okay, sorry, ini 8 mm, times rm square over, okay, over mm, okay, over mm. So what happens now is, okay, apa yang berlaku seterusnya, saya padam sini dulu, okay, saya kasih dia nampak kemas sedikit. Okay, so apa yang terjadi? So ME is 81 mm, and then RE is 4 rm. Remember the square, okay? So what happened next is, students, they will expand the equation first. So AGE over AGM is then equals to 81 mm over 16 rm times rm square over mm. So apa yang terjadi? Okay, you guys then cancel out the similar term. Also can, okay, nothing's wrong with this method. So terpulang pada kaedah mana yang anda rasa lebih senang, right? So you substitute AG equals to 9.81. Eventually, you will get AGM. It is also equals to 1.9 ms negative 2. So both method, they are all correct. Okay, kedua-dua method, semua betul. Dia terpulang pada anda. Anda rasa yang mana lagi satu senang nak pakai? The green one or the red one? Then you just use it. Okay, we don't have a fixed answer in physics. It depends on which one you think is easier for you to use it. All right, so this is the last questions. You write it down. And then if no questions, then you may leave the class. Right. Okay, so dua